Hi, my name's Leo and I'm a boat builder and a sailor. Back in 2017 I bought a very old and quite famous wooden sailing yacht for the price of $1, and since then I've been rebuilding that boat from the keel up with the help of a lot of amazing people. Now in this video we've got a lot of really exciting stuff going on. We're going to have a lot of woodwork on deck and below deck, and I'm really happy to say that our diesel tanks are going to be here, and so we're going to be able to test those and get them in the boat. But first of all, we're going to catch up with Patrick, who is making Tally-Ho's mast step. Now traditionally on a lot of wooden boats, the mast step is a big chunk of timber that accepts the heel of the mast and spreads the load of it across all the floors and the centerline of the boat. Now Tally-Ho's mast step is a slightly different arrangement. It's sort of in two parts, and the main load spreading part is already part of the centerline below the floors. So the piece that Patrick is making is more or less just the mortise part, which accepts the tenon in the heel of the mast and stops it from moving in any direction. But it's still a pretty substantially sized piece of Purple Heart.
All right, so I just cut out the block that makes up the general dimensions of the mast step. I'm going to pattern out for the mortise that's going to accept the tenon of the mast. I also have to cut out some slots that will fit around the keel bolts, and I have to make a channel across thwartships across the bottom of the mast step to accept a bronze floor that goes across there. Yeah, so all of those slots that I'm cutting have to have a way for water to escape, so we don't have any places where we can trap stagnant water in the mast step.
What are you waiting for? Go build it.
Okay. Okay, bye. This is the mast step.
Yeah!
Yeah, dude.
Am I supposed to watch my language for all the videotaping going on?
He usually bleeps them out with machine noises, you know?
So Patrick's mast step is coming along great, and in case you're wondering, the bronze bolts which go across it are just to hold it together, stop it from splitting or checking with the sideways force that might be on it from the tenon in the mast. Now Patrick's got to get a coat of paint on it, and then we'll see where and if it fits in the boat. But before that, we've got an exciting delivery, our diesel tanks. Now I ordered these a long time ago, and a lot of consideration was put into their design and material, because you can make fuel tanks, diesel tanks, out of many different materials: mild steel, stainless steel, aluminium, titanium, Manel, fiberglass, welded plastic, roto-molded plastic, even plywood. You name it, basically it's probably been done. But of course, each material has its pros and cons in regards to cost, ease of manufacture, durability, longevity, corrosion, and so on. So after a lot of consideration, I decided to go with plastic welded tanks. Now these are not that common because it's a relatively new technology, but they're basically made by cutting sheets of poly and welding them together using a heat welding technology. And in theory, if they're well made, they should last really, really long time, potentially longer than any sort of metal tanks, because even stainless steel and aluminium do actually corrode in certain conditions. Now I ordered these tanks over 6 months ago, because even then there were jobs in the engine room which couldn't happen until the diesel tanks were in. At this stage, with the delay, it's been holding us up quite a lot in that area. So I'm really glad they're here. Now we can get them in, and hopefully we can go ahead and work on all those other jobs in the engine room.
Hey Clifton, what the hell are these?
These are tanks.
Tanks for what?
Fuel tanks. Diesel.
Diesel, baby.
I believe these are the diesel tanks. For it.
So we're currently pressure testing the diesel tanks. Joe is using, what are you using, Joe?
Dry nitrogen, yeah, for the gas, because I have it for doing refrigerant. I'm using my refrigerant gauge set to measure it in. I calibrated it to atmosphere, and then putting in exactly 3 psi, because I'm a little afraid of the plastic tanks. I don't want to blow it up.
So essentially this is just to make sure there's no leaks in the tank, and well, that's it really.
Yeah.
But we're not doing it to a really high pressure, we're doing it to sort of the minimum acceptable pressure, because we're being cautious. Is that at 3 now?
Yeah, it's at 3 now. You can
Cool.
see that the ends are starting to bulge a little bit, but that's to be expected. If you take 3 psi and apply it over an area that has, 300 square inches, that's a lot.
Yeah.
So yeah, you want to be very cautious about.
So that little bit of bulging there, that doesn't worry you at all?
No, not at all. I totally expect it. Yeah.
Cool.
Yep.
That's good. And then do we wait a little bit to see if the pressure drops?
Absolutely. Yeah, we could bubble test the fittings, make sure we're not leaking from the fittings. Looks good. Yeah, I mean, it's a good enough leak that it's just blowing the stuff out. I can hear it even audibly. I can see it too.
So we've got a pretty big issue with our diesel tanks when we pressure tested them, only up to 3 psi. We found that there are quite a few leaks in them on some of the seams, in the access panel, and in the threads. The threads are all messed up, and even using a lot of PTFE tape and stuff, we couldn't actually get the threads to seal. So that's a real big problem. We've been waiting for these tanks for a long time, so there's a lot of jobs which we haven't been able to do until these arrive. So I'm not really sure what we can do. We don't have a lot of time to spare with these. They need to go in the boat, but obviously they can't go in the boat if they're leaky. So got to figure out what to do. For now, we're going to put them in the boat and see if they actually fit, and then think about what happens next. This face is the top.
Yeah. Okay. You want to rotate it?
Which way we're going? That way?
Yeah.
No, other way.
Other way, I think you could.
You can go 270.
I don't think so. I think it's... Wait. Oh shit, it's the other way. Yeah.
Who would have thought?
I just realized.
Fuck, this is the weirdest shaped thing, dude.
You're cool.
Hold on, hold on.
Not someone's paying attention.
Oh, now it's... You guys got it?
I'm on now.
You can help keep it upright. Yeah.
Yeah. It is slippery,
Hands
huh?
on y'all. Yeah, that is awkward, dude.
You okay, Joe? The outlet could have migrated down, so that would come up with hatch as well. So we need to get that in and out.
Well, hey there, Richard.
How's it going?
It's going good. Those are going to be drawers, and then the bottom two are shelves.
These 2 shelves.
Yeah.
Yeah.
What goes on at the very bottom, at the underneath, right by the sole? Is that just
Right
going to
here?
be a little kick zone?
Yeah, it's the work area for your feet.
Yeah. How do you like making the cabinets out of that cypress?
It's great secondary wood. It's perfect for drawers and stuff. Very stable.
Yeah.
You know, it's,
You don't expect a lot of warping and whatnot out of that?
no, not like if it was oak or something.
Yeah.
No, it's stable wood. I think the false fronts, the fronts of these are going to be oak, I believe.
Nice work, man. It's beautiful.
Well, let's go together.
Hey Richard, what's that tool you're using there?
Well, it's a rasp of some kind. It is, we're using it to relieve to get this down over the rivets in the frame. So they need, I drilled them, but they need a little more relief.
I like how you're using it on the corner drill there. It gives you a bit better leverage on it by the looks of it.
I can push on it a little better than a regular drill.
Mm-hmm.
Yeah.
Yeah, smart.
You just got to get it going on the right direction. It's great on hemorrhoids. Highly recommended.
Yeah, you want to check it out?
Yeah, I do. Well, I'm fitting the starboard top for the workbench. It's biscuited together. You can kind of see some of them on this side, but the joints are all got, what do they call them, dominoes. We mortise in there, and they're all fit together. The same with the breadboard here. It's dominoed in. And turns the corner there. Yeah, it's a interesting shape.
So deciding how to resolve this diesel tank issue has been really challenging. One of the main difficulties for me is the timing. So many jobs on the boat that can't happen until these are in, that are already held up, that anything that delays this further is a real problem. Now, I don't want to blame the manufacturer for the delay in getting these tanks completely. I know they had some unexpected difficulties getting the material and some unexpected health issues as well, so I do sympathise with them for that. Now, I did find a local plastic welding specialist and had him come and inspect the tanks because I was hoping to just maybe get the leaks repaired and get them put back in. However, his assessment of the tanks was that the welds were not done properly and the tanks were generally not up to standard. Now, the manufacturer says that they do have confidence in their welds and the quality of their tanks, and so I don't want to pass judgment either way, but it did make me hesitate even more about putting these in the boat. Now, I'm not going to name the manufacturer and I'm not going to say anything definitively bad about them. For me personally, I don't think these tanks are up to a marine standard, certainly not up to my standard for this boat. So ultimately, there's not really much of a choice. I'm going to send these tanks back. But credit to the manufacturer, they have said they will give me my money back. They also did offer to take them back, cover the shipping and repair them and send them back to me. So they have been very reasonable in some ways. So that's what I'm going to do. I'm going to send the tanks back. Hopefully I will get my money back and we're going to have new tanks made. And that is going to be a big holdup. But we're going to hopefully be able to work in other areas of the boat and keep busy. The main issue is systems stuff. But hopefully our water tanks will be here really soon, and that'll enable us to get started in the galley and the saloon with framing up the sole and all the things which go above the water tanks. Now, the next question is, what will the new tanks be made of? And we're going to talk about that right after we've checked out some of the other work that's going on the boat.
My name is Nick. I currently live in Chattanooga, Tennessee. I've been woodworking for about 10 years, but predominantly I do hand tool woodworking. I'm here to help out with the project, learn a bit on the way. Specifically, I'd love to learn a bit about machines and just boat building in general.
All right, dude, what are you doing?
I am mortising out hinges for the hatch that goes on the workbench. In the front of the boat?
The bow of the boat.
Bow of the boat.
You can call it the front though. And it's above the chain locker, right?
Yeah, that's right.
Just say it's above the chain locker.
It's above the chain locker.
There you go.
Right? I feel like that's good enough.
Yeah, we should just roll with that.
I mean, Leo wants to throw it in the water, so. Alright, let's see. We might have to do a little more fitting in the front, but...
Oh, mama!
You like that?
Say hello to the chain.
So this four-peak area is coming together really nicely. It's hard to film in here because it's so small, but Richard has been doing some really lovely work on some cabinetry in here and the workbenches themselves. Nick has done some fitting and oiled them, and they look really nice. So this big workbench surface goes all the way around behind me. There's quite a bit of room on this side. There's some cubbies down here for storage, and then some big shelves down here, and these two drop drawers. So you have to open these by lifting them up a little bit, otherwise they won't come out. And they're actually really secure. Even if the boat is moving around a lot in a seaway, they don't tend to fall out. Now over here we've got the chain locker and this nice simple hatch to access it. You need access to the chain locker to unclog a tangle or a jam, to flake the chain as it's going in, or just to clean it. And the chain will run through a spurling pipe which comes through this work surface up through the deck and to the anchor windlass or the capstan. This lid will have a little catch to hold it open and another catch to hold it closed. Up here there's quite a bit of space, and I'm not certain what's going to happen up here yet. We might have a fold-out bed up here, which would probably be a pipe cot, a canvas bed in a frame or something like that. Or this area might just have some shelves and be more storage for tools, for paints, materials and things like that. But it's really fun to see this area come together and sort of imagine doing some work here, doing woodwork, painting, rigging, whatever needs to happen. I think it's going to be a pretty important part of the boat. So now that I've finally resigned myself to getting rid of these tanks and getting new tanks made, we've got to decide what material those new tanks are going to be. But first, a little in general about these tanks. There's two tanks, obviously, one on port side, one on starboard side. They go above and slightly aft of the engine, right outboard, and they fit the shape of the hull outboard. The port side tank is going to be about 160 gallons, starboard side will be about 120, so probably a little over 280 gallons total. Let's say, for the sake of argument, that the engine will burn 1 gallon an hour, which is probably about right at sort of cruising speed, maybe 1800 RPM. Then that will be 280 hours of motoring, which is about 11 days, and at an average speed of 5 knots, that would give a range of about 1400 miles. So pretty good range, pretty big diesel capacity for an auxiliary sailing yacht. Of course, the tanks don't have to be kept full, and I probably won't be keeping them full a lot of the time when I'm just sailing coastally or whatever, but if you are making a long passage, it is really nice to have a large range. If you have to cross, say, a really large high pressure zone, like in the Pacific, that could be 1,000 miles across. Or if you want to do a passage like the Northwest Passage, where there's a lot of high pressure in the summer and not much wind, again, you could be motoring for several weeks. Of course, I haven't factored in the electric motors, the hybrid part of the engine, into this equation, and that's because they really won't be used for propulsion during long passages, probably. They're more for inshore sailing, getting on and off the anchor maybe, or on and off a marina dock when you don't want to start the engine for a short duration. Now, it's quite likely that that will be the case most of the time, because the boat might spend a lot of its time sailing inshore or just a little bit offshore and not using the diesel engine for propulsion during that time, although of course it will be run for a few hours every week or so to charge up the batteries. And so even if you're not motoring a lot, say you're somewhere really out of the way where there's not a lot of diesel facilities, you can be self-sufficient for a long time using all that diesel just to charge the batteries, say, for domestic use and light motoring. Anyway, back to the diesel tanks. We've got to decide what material we're going to use, and there's lots of options. I've kind of gone off the idea of welded plastic based on the experiences we've had. I was also advised that with the heat cycle of diesel tanks in an engine room, the lifespan of that type of plastic might not be as long as we thought it would. I love the lightweight nature of welded plastic tanks. I love the idea of no corrosion, but with these tanks, because they're so built into the boat, they're so difficult to remove or change or replace. I think it's probably really important that we go with a really tried and tested technology and something that we know is going to last, you know, hopefully 40 or 50 years. Roto molded tanks are pretty cool. They're really durable and long lasting, I think, but they only come in stock shapes and sizes, so we'd lose a lot of capacity by not being able to follow the shape of the hull. In terms of metals, there's lots to choose from. It's quite exciting to think about titanium or Moreira tanks. Moreira is incredibly noble metal, well they both are actually. Titanium is extremely strong. The problem with using those materials is A, the cost, B, finding someone that can actually weld or braze them, and also they're so noble that actually it's difficult to attach any other metals to them, because attaching those metals to them will just make those other metals corrode instead. Stainless steel seems like an obvious choice for diesel tanks, but it actually can suffer from really bad crevice corrosion, and so at least here in the United States it's not recommended or used for diesel tanks, and it seems like there's very few people around that would make them. Now I'm sure there are lots of other options which may be more or less obscure, but it seems like we're left with two obvious practical options here really, and those are mild steel and aluminium. Now using mild steel tanks might seem like a silly idea. Of course steel does rust, but actually it's a really tried and tested tank material, and the trick is to coat it properly on the outside with a really thick epoxy paint, and that will stop it from corroding, from rusting on the outside for a long time. The inside of the tanks don't tend to rust because of all the diesel in there. Recently I've been hearing a lot of stories of steel tanks coming out of working boats 80 years old and still being in relatively good condition if they were painted properly, and that was before we had such amazing epoxy paints which can last for so long. The main issue with steel tanks for me on this particular project is their weight. They are quite a bit heavier than aluminium tanks, and although that shouldn't really matter so much on a boat like this, I am a bit concerned about the boat being stern down and the centre of gravity. So I am trying to reduce weight, and these tanks are quite high up and they're right at the back of the boat. Now aluminium tanks are lighter. We'd probably save about 200 pounds between the two tanks by using aluminium. And of course aluminium doesn't corrode in the same way as steel. However, it does corrode. Aluminium makes an oxide coating when it's in contact with oxygen, but anywhere where there's no oxygen, say a place where water is sitting or something damp has pressed up against the tank for a long time, it can actually corrode quite fast, and it's quite common to hear of diesel tanks with water inside, just even a little bit, which collects at the bottom of the tank, forms a sort of sludge, and then will just eat its way through the bottom of the aluminium tank, and suddenly, could be 5 years after you've put the tank in, you've suddenly got the bottom rotted out of it. Now it does seem like most of the issues with aluminium tanks comes from poor installation or poor upkeep, basically not having proper airflow or ventilation, not having proper mounting brackets that allow water and air to pass around them, or not draining the bottom of your fuel tanks. So hopefully if we did a good thoughtful installation on these and they're maintained, perhaps aluminium tanks could last as long as steel tanks. Certainly the weight of aluminium is a big advantage. If it wasn't for the weight, I think I would certainly go with properly coated mild steel, but with that weight consideration I'm just not sure, and so I'm trying to figure out which is more likely to last longer basically, and it's a very difficult question because there's all sorts of unknown factors. But I'm keen to have some input, so if you have a lot of experience with both of these tanks or one or the other, or good or bad installations and so on, let us know, and we'll be having to make a decision really soon in the next few days or the next week, so we can get these tanks here as soon as possible and continue with our engineering work. For now though, that's about all we've got time for, so thanks a lot for watching, and a massive thank you to everyone who has donated or otherwise supported this project. It does make a huge difference, and it means that we're able to keep on doing this work, and I'm able to keep on making and editing these videos, so I really appreciate it, and I'll see you next time. Cheers.